Assalamu alaikum students. Bismillahirrahmanirrahim. Welcome you in my lecture 9 structure analysis program 2000. In the previous lecture we will basically discuss a little bit about the design, the analysis of a cantilever beam. Okay, that was actually a cantilever beam, that was not an overhang beam. So I make a mistake, please pardon me. That is a cantilever beam, not uh, not an overhang beam. Clear? So here you can see that this is a new example, and we have to also to draw a shear force and a moment diagram. Taken the same example from Hebler book 7th edition, okay, chapter 6. Clear? So let's see how we will assign these joints, okay, and how we will apply the moments. We can assign this joint in this way, and as well as we can assign this joint in an usual way, okay, in an usual way, like in this shape. Clear? So both will give you the same result. Clear? Both you can assign this in this way, you can, but make sure that in some time we need to assign the joints in this shape as well. And in that, for example, if we are analyzing the inclined frames members, so in that case it will matter, okay, its pattern, its shape matter, but there it don't matter, okay, because it will give you the vertical reaction. That vertical reaction, if this support exists in this shape, will be in this shape, will be acting in this upward direction, and as well if the support is in this pattern, it will give you the same vertical thrust. So it don't matter, okay, for the present case of beam. Clear? So let's see, we will solve the example, okay, that how we will solve this example. Clear? So let's see. Make sure the units are kilonewton and meter, okay. Select kilonewton meter, new template with a span of 1. A total span length is 9 meter. Clear? And this is, remove this window, make sure you will be in XY plane. This support is hinge and this is a ruler. Clear? You just need to disable the self-weight multiplier. So define section properties, frame section, modify and show set modifiers, and make these two equals to 0. This is approach 2, you can say, for self, that how we can disable the self-weight multiplier. That in analysis the SAP don't consider the self-weight of the structure. Clear? So select the beam, assign, and there you have a very different type of loading, okay, a very unique loading. You can say that there is uniformly varying load, which is maximum at 0, comes out to be 0 at the center, and then goes up and reaches to a maximum value at the peak distance. So let's see how we will assign. Clear? Self-weight multiplier is 0. We already did that step. Units should be kilonewton, and Assalamu alaikum, dear students. Bismillahirrahmanirrahim. Okay, sorry for disturbance. Okay, global gravity. Okay, now at 0 distance you have a maximum intensity of the varying load, that is 50 kilonewton meter. At 0 distance you see you have a 50 kilonewton meter, and then at a distance of 4.5 you have an intensity of loading is equals to 0. So that is 0, and then at a distance 9 meter you have intensity equals to 50. So let's see, this is the load distribution. Clear? You just click model do not run, okay, and run now. Save, this is simply supported shear force and bending moment diagram, shear force diagram and bending moment diagram for a simply supported beam. Okay, so save the project, and this is the maximum bending moment. If you are want your reactions, so 112 and 112. Clear? The reactions are okay. What will be the shear force and bending moment? Okay, select this option, frame, shear T2, and okay. So you see the shape of the of the curve, which is 2-degree curve. Clear? And remember that always for a uniformly varying load, for a uniformly varying load, the shear diagram will always have a curve of second degree. Okay, this will be a second degree curve, and in a moment diagram you will always have a curve of 3 degree. Clear? This will be 3 degree. You must keep in mind this. This is very important. Okay, and for always a UDL, okay, a shear diagram has a 1-degree curve. Okay, and in the case of movement, okay, it has a 2-degree curve. So this is the correlation of this curve in shear force, bending moment with the type of loading. Clear? So this is the shear force diagram, and if you are interested to see the moment, so select moment 33 and OK. This is the maximum moment, that is 169, you can say. Okay, so let's see, 169. So the calculation is okay, and the analysis is completed. And okay, so this is the end of this lecture 9. If you have any question, any doubt, please comments on my channel, and as well as you can contact me.